Study guide for section 9.1, we're going to use ratios and proportions. A ratio is a comparison of two quantities, and what you're going to use is division. So you're comparing two things with division. The ratio of A to B can be expressed as this fraction, A divided by B, or A over B, where B is not 0. The ratio can also be written this way, A colon B. And you can write it like this also, A to B. An equation stating that two ratios are equal is a proportion. So A over B equals C over D. That's an example of two fractions that are set equal. That's a proportion. For any numbers A and C, and any non-zero numbers B and D. So you can't have your denominators as zeros. In any true proportion, the cross products are equal. So what that means is A times D is the same thing as B times C. So we're going to use that to our advantage. Anytime we see a proportion where we don't know one of these four values, we're going to cross multiply to solve to find that value. And that's what they do in this example. They're going to take 11 times x to get 11x. They're going to take 16 times 44 to get 704. And then you divide by 11 to get your mystery number 64. So what that means is 11 divided by 16 is the same thing as 44 divided by 64. And we'll check that work right now with our calculator. 44 divided by 64. If we reduce this as a ratio, notice how it gives you 11/16. That's how you know that's the answer. So what we're going to work on in this section with ratios and proportions, we're going to reduce some ratios. They're going to give you proportions where you're missing one of four quantities. Then you're going to cross multiply and solve for the missing one. So for exercises 1 through 4, we're going to use the table to find the ratios. Express each ratio as a decimal rounded to 3 places. You don't necessarily have to do that. I'm comfortable with you just writing the ratio. We want to do a ratio for games won to games lost for the Hawks. We know that the Hawks have won 16 games, and we know that they've lost 13. So the ratio would be 16 to 13. You could write it like this, or you can write it as a fraction, 16 over 13. Totally up to you. Maybe I'll just write it out. Any one of those 3 ways are acceptable. Number 2, games won by the Hawks compared to games won by the Tigers. 16 to 15. Pick your favorite way to write it and just go with it. Number 3, games won to games played for the Tigers. Be careful here. Games won is 15. Games played would be your 15 and your 14. Either you win or you lose the game. We're assuming there's no ties here in this situation. So 15 to 29 is your ratio. Number 4, games won to games played for the Mustangs. Mustangs have won 12 games and they've played 28 games. So watch yourself there. And this isn't reduced. So I'll reduce that. 12 to 28 are the actual wins in games played. But as a ratio, we can write it a different way. We can say it's 3 to 7. So they've won 3/7 of their games is what that means. Next section, we're going to solve each proportion by using cross products. So remember, we're going to cross multiply. When you have two fractions that are equal, their cross products are the same. So 28 times x gives me 28x. 9 times 84, I'm going to need some help with that one. So I'm going to type it into my calculator. Gives me 756. Now we want to get x by itself, so we're going to divide by 28. X ends up being 27. Quick way to do this, just multiply your 9 and your 84 and then divide by 28. That's the quick way. Number 6, 4x times 18. That gives me 72x. That's going to be the same thing as 3 times 7, which is 21. And this might look weird because you're going to divide 21 by 72. And that gives you this. I don't think it reduces. Oh, excuse me, it does reduce, 7/24. So our missing number there is actually a fraction. Number 7 is a good problem to look at because we have an x on both sides of our proportion. We haven't seen that yet. So we're going to take 7 times the quantity, x plus 3. That's one cross product. The other cross product will be 5 times the quantity, x plus 5. Then we're going to distribute to get x by itself. We're going to subtract 5x from both sides. We'll subtract 21 from both sides. And then, kind of out of room, but you can see that x is 2. You can always check to see if your proportion is correct by plugging your x value back in. 2 plus 5 is 7. 7 divided by 7 is 1. 2 plus 3 is 5. 5 divided by 5 is 1. So we get 1 over 1 equals 1 over 1. So this is our correct answer. Anytime you solve a proportion, you're able to plug back in and see if your answer is correct. Number 8, use a proportion to solve each problem. If 2 cassettes cost $14.50, how much will 15 cassettes cost? So we're going to write a ratio of number of items to cost. If you're buying 2 things, like cassettes, and it costs $14.50, how much is it going to cost? That's your unknown, is your cost for 15. Make this a proportion. 2 cassettes cost $14.50. 15 cassettes cost how much? Cross multiply. Remember the quick way. I'm going to do $14.50 times 15, and then I'm going to divide by 2. So it'll cost $108.75. Number 9 says, if a 6-foot post casts a shadow that is 8 feet long, how tall is an antenna that casts a 60-foot shadow at the same time? This is an interesting scenario that you can actually apply if you're trying to indirectly measure the height of something. So we have this object, like a post, and it has a shadow length. We're going to write a ratio, that object's height to the shadow length. A 6-foot tall object has a shadow length of 8 feet. How tall is the antenna? That's how tall the object is. If the shadow is 60 feet. You can definitely measure the length of something's shadow. It's on the ground. How tall is the antenna? That's a little bit tougher to measure. But if you measure something nearby and obtain this data, you can do a proportion like this on your own. We're going to do 6 times 60. And we're going to divide by 8. So x is 45. How tall is the antenna? 45 feet tall.